Hello, we are the Smart Wobble board with knee tracking. Our team manager is Natalie Zanolato, our software engineer is Hannah Roach, and our hardware engineer is Tiara Higuchi. We've decided to focus on ankle sprains because it is a widely common injury for athletes and anyone being physically active. Additionally, athletes commonly re-injure their ankles due to insufficient rehabilitation programs. Because of this, our device is tailored towards physical therapists and athletes.
Some current treatments used to retrain the ankle are the Y balance test and a smart wobble board. The wobble board can be used to improve a person's range of motion, ankle strength, and proprioception. However, the Y balance test is mostly used to determine a person's risk of re-injury or return to sport readiness. The main difference between current treatments and what we are proposing is that during rehabilitation, the knee may compensate for lack of strength or mobility in the ankle, which may lead to a slower overall recovery.
To pursue this design, we first had to create a 3D printed fulcrum to go underneath the wobble board. This fulcrum had to have a hollowed out space for the sensors and pathways for the wiring. We also wished to implement the holes needed to secure the fulcrum to the wobble board with screws. On the bottom drawing, you will see the fulcrum sleeve that we have designed. We created this to ensure that the sensors would have no additional movement during the exercises. Here you can see the trial and error we went through when creating the fulcrum and fulcrum sleeve. In the next video, you will see how all of these different components that we have worked on throughout the year interface together. To begin, you connect the USB to the printed circuit board that contains our sensors. This is then placed inside the fulcrum and the sleeve is placed next. Then the fulcrum is inverted and secured with screws and washers to the wobble board. Our latest 3D printed component is a stabilizing device, as the wobble board has to be calibrated before the exercises can start, and with the bottom being a sphere, it is difficult to get a correct reading. Now we will show you how the knee sensor components work together. First, you place the printed circuit board inside the inner chamber of the knee device. Next, the inner chamber is slid into place and secured with tape. The USB is connected, and the whole device is secured to the knee strap with Velcro. The knee strap is then secured to the patient around the thigh and placed at the top of the kneecap. This design allows for a wide range of patients as the knee strap is adjustable.
This is a demonstration of our device in action. As you can see, the knee visual on the top is relatively still, while the ankle visual on the bottom is moving with great mobility, showing that this is a relatively good performance of the exercise. This is our most recent development in the project. By taking the recorded data files from the sensors and entering them into MATLAB, we were able to create graphs showing knee and ankle motion. This graph shows the knee motion while performing wobble board exercises. The beginning of the graph stays around 0 acceleration because the patient was tilting the wobble board front and back, which does not involve any knee movement. The patient then moved their knee to the right, starting around sample 1200, and then left, starting around sample 1500. A physical therapist would see this graph and be able to tell the patient to focus more on keeping their knees steady while tilting the board to the left and right. By having a graph, a physical therapist is able to have quantitative data to support their course of treatment.